Okay. UVM tutorial. Basically, test bench hierarchy and block diagram we'll see once. No, this is look too high level. You forget about it. After that, we'll go step by step. UVM test. UVM test is the topmost class. UM test is a topmost class. The test is responsible for configuring the test bench, initiate the test bench components, construction by building the next level, next level down in the hierarchy environment. Next level, there will be a environment. Wait, I downloaded one thing that I'll show you. Better, you'll get a good quality. This is how. Okay. Top,
Okay.
top layer is test. Below that environment. Environment contains generator, driver, monitor, scoreboard. These are outside the environment and test. Interface and DUT.
Yes.
Wait a second. హలో జూమేనే ఒక్క నిమిషం ఉండు నేను మళ్ళీ షేర్ చేస్తా ఓకే this is clear, right? This is as simple as that. In a generator, what in this there is a transaction class. There you have pin level information of the DUT. Okay,
Yes.
and there is a driver. Driver, what it will do is it will drive the information packet to the pin level information of DUT through interface. From interface, it will get the data from monitor and it will build the packet. It will give it to scoreboard. Scoreboard has a reference model as well as this output from the DUT. These two should be compared. If those two are matched, then it is called match. Otherwise, mismatch. That's as simple as that. Okay.
The data that driver and monitor is giving, that should be mismatched.
The data,
The driver is giving and to the scoreboard and monitor is giving, that should be matched, right?
yeah, you are right. Initiated test bench component construction by building the next level down hierarchy environment. These things and all don't read. See, I'll tell you. First, there will be a test. Upon test, there will be like a environment. All instance should be instantiated in environment. Environment is instantiated in test. Okay. UVM agent. UVM agent groups the UVM components specific to an interface or protocol. Okay.
Okay.
Wait a second. Why is this? Specific to interface or protocol. Example, groups components associated with BFM. Okay, BFM means bus functional model. Okay, this will
Okay.
be architectured between whenever there is a bus function of m- m- master as well as a slave. We will use the word called BFM, bus functional model. The components are an agents. Next, UES sequence item. US sequence item defines the pin level of activity generated by agent. Whatever this transaction will do, that thing will be done by pin UVM sequence item. To drive DUT through driver or the or through activity has been observed by the agent placeholder. The activity monitored by the monitor on the DUT signals. This is focus on DUT signal. UVM driver responsible for driving the packet level data inside the sequence item to the pin level DUT. Okay, pin level DUT means DUT have pins. So to that pins we need to give signals.
Okay.
Okay, UVM sequence defines the UVM sequence in which the items are needed to be generated and sent and received from the driver. Okay, send generated send or received to from the driver. US sequencer responsible for routing the data packets, data sequence item generated in the sequence to the driver or vice versa. Okay, these things sequencer will do. UVM monitor observes the pin level activity and the interface signals and converts into packet. Same like SV only. Okay, and which is sent to the
Okay.
component such as scoreboard. Scoreboard receives data items from monitors and compare it with expected values or reference model values. Expected values can be either golden reference values or generated from the reference model. From the reference model, we will generate it and we will compare. For a detailed explanation for such components and methods, UVM tutorial, UVM test bench diagram. Yeah, this looks very, compared to my diagram, this looks very neat and elaborated. See, this is UVM sequence. Okay, got it. Okay,
Okay.
sequencer. In that sequencer will be there. On that sequence item will be there. So these are called TLM ports. This port is called export and this port is called import. Okay, square is called import and this port is called export. It is exporting the data and it is importing the data to the driver. Okay, then there is no ports here. Again, from monitor to the scoreboard, there is a uh, analysis ports. We can analyze. Okay,
And the scoreboard is having a round board. That means it is exporting. It is
yeah,
not exporting now. The data is getting
very good,
imported into the
very
scoreboard.
good, very nice observation and very good also. This is importing, this is exporting. Very good. Okay,
But the same things becomes different for the driver, for the sorry, this driver.
Sequencer. Yeah,
The
yeah.
round pin is exporting and the driver is yeah, importing the data from the sequencer.
But this is like, see, analysis port means it's like a broadcasting. It is broadcasting for so many things. There will be like a configuration DB, config DB, and all will be there. Those also takes these pockets. This is one-to-one communication, one is to one communication. This is one is to many communication. UEM
Okay,
testbed diagram with multiple agents and multiple instances of each. See, sometimes, see, these are the multiple agents and multiple sequences. There will be multiple, see, when this will happen means if you are making a very big circuit like SOC, okay, uh, M,
okay.
MyPy, you know MyPy?
My pi, I don't know.
I explained you MyPy already in SV. MyPy is nothing but
Okay,
basic reference model of this mobile communications hardware. In that there are so many sensors will be there. There will be so many clock trees will be there. Clock tree will be there. There will be a processor. There will be a RAM memory. There will be ROM memory. There will be a camera. There will be so many things will be there on that uh, uh, PCB cell phone, right? That follows, that has to follow MIPI standards, MIPI standards. Okay.
okay. So
Now,
the actual values, the values that we will get, we need to we need to match it with the my pi.
no, no, there you will get here likewise multiple agents. Okay.
Okay,
That application I am telling. Okay, we'll see basics. UM sequence item example we'll see first. UM sequence item, UM transaction. Transaction here also we will use pin level information as well as the UVM sequence also we can write. Here all the classes are derived classes, are child classes from the parent base class. From the base class, these are derived classes. Okay.
okay,
Compare, copy, pack, unpack, print, record, set name, set get name, get type, get UVM object components. Okay. There are like UVM object and UVM component. Uh, these two are only two types will be there, UVM object and UVM component. Okay. Those modules I'll elaborate as we go move on. As we go ahead, I'll explain. UVM utility macros. What is meant by a macro? Macro means predefined code simply. That is written. That is written for future purpose. Okay, that we will use. That won't. That cannot be simulated or do. Okay, there won't be code, right? There will be code written somewhere. It is like a header file. stdio.h of C language. There won't be any code, right? But with the help of that, we can use all math functions. Okay, addition, subtraction,
okay,
multiplication, division, exponential, reminder, everything we can use. Here also such types. The utility macros provide implementation of the create method needed for cloning. What is meant by cloning? Typing in the same way. And the get type method needed for debugging with objects no field macros. This is called tick. This is called, see, like okay, escape below one key is there, tick. The tick is UV, tick UVM. Okay, object utils type. This is called factory. This is called basically factory. Factory registration has to happen for each and every component which you will inherit from the base class, has to register in a UVM factory. This is mandatory and you shouldn't escape from it. Objects with tick utils begin, UVM field, UVM object. This is very depth. You don't need to know all these things. Okay, these things are also too much. Flag. Okay, flag means it's like a flag signal. It means it rises and shows some information. Okay. UVM all
Okay.
on, set all operations on default description. UVM default uses default flag settings. UVM no copy, do not copy this field. UVM no compare, do not compare this field. UVM no print, do not print this field. UVM no different, do not print this field in it's the same as it is. UVM no pack, do not pack or unpack this field. UVM physical, okay. Treat this is as a physical field. Use physical setting in the policy set field. All these things. Okay. Radix. Radix things means binary. Bin means binary. D means decimal. Unsigned means positive only. Oct means octal. Hex means hexa. Time means dollar time. Sequence item. Now only we have seen sequence item. Don't read this theory. Okay. Directly go to example.
Okay.
Okay. You can understand that theory, everything is from example only. So no need. There is like a class memory sequence item extends from UVM sequence item. UVM sequence item is already there. This entire code is written in a abstract form. Okay, abstract form.
Okay.
The thing in abstract form, how to write any code in abstract form? Prototype form. How to write any code, any class
I don't know.
with which keyword?
In an abstract form. I don't know. I don't remember it.
Virtual keyword. Methods or para, parameters or class we can write with virtual class,
Okay.
virtual method,
Okay.
virtual function, virtual task.
Okay.
Those things I can extend here. Okay, mem sequence item, maybe it's a memory. Okay, for a memory what are all there should be there? Address should be there. Okay, reading or writing,
Okay.
only two things. Control information. Rand bit 3 down to 0 address 4 bit, which means depth is 16 bit. Okay. 16 locations are there in the memory. Okay. Rand bit.
True.
Write enable, read enable. Okay.
Okay.
Write enable means if write enable is 1, which means write. It will write into that memory, into that address. First, it will pass the address. On the address, it will write the data. Okay. Read means
Okay.
from the same address, whatever may be the address we will give from read, it will read the address. Rand bit,
It will read the same data that is written on the address.
not only same data, any data it can read. See, I'll explain here.
Okay.
Paint is there.
Chai below.
See, these are the address locations, memory address locations. This address location is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 locations are there. Okay, in any address location they can write, or from any address location they can read. Okay, based
Okay.
on the address. It is not mandatory that one address has written here. The same address we will write back, read back. That is called FIFO,
Okay, first in, first out.
first in, first out. That's why FIFO have so many applications, so many places we will use FIFO.
Hmm.
RAN bit W data, write data, analysis information. This is called payload information. Analysis information means bit is round down to 0, read data. Okay.
Okay,
Utility and field macros. Tick UVM object utils begin. Here we are beginning, here we are ending. Here we are ending. Understood? Beginning and ending. In between, field integer, adder, comma, UVM all on. Write enable, comma, UVM all on. Read enable, comma, all on. So we are utility, we are setting utilities. This is it. Next,
okay.
constructor. How we will write constructor with the function, right? Okay.
Mm-hmm.
Zero,
Mm-hmm.
zero delay should be there. To write a constructor, it
Mm-hmm.
should take zero delay. That zero delay will happen with only function, not with the task. So we'll go for function.
Okay,
We can write with the function
okay,
also, task also, right? But we cannot. Okay. It won't take zero delay. It will take some delay. Function won't take any delay. String name. This is the class name. Mem seek item. Same thing. Okay.
okay,
Mem seek item. Okay. Class name. Derived class name or child class name. Constraint. We are writing a constraint. Write, read, see. Here, write enable is negation to read enable constraint we are putting, because this is like a
mm.
this is like a off duplex. See,
So what W,
no communication is
it is
simplex.
read write constraint, right?
Yeah, read write constraint. This is a off duplex communication. Okay,
What is off duplex
I'll
communication?
explain. Simplex communication we don't use nowadays. There are three types: simplex,
Okay,
half duplex, full duplex. Simplex means
okay,
communication happens from only one way,
okay,
from
duplex,
transmitter to the receiver. Okay,
okay, okay,
communication happens. But in half duplex means communication happens from one point to another point, not simultaneously, one by one. First,
but one at a time. We studied it in eighth class,
yeah, yeah. First we will
seventh or eighth class.
First, we will send the data and we will wait. We will get the acknowledge or we will get the read data. It will send again. After that, this will send. After one by one, it will send the data. Okay, from
So
master
it is
to
off
slave.
duplex and on duplexes. Both can do the communication simultaneously at the same time, right?
Very good. You are too advanced. I know.
We have already studied it in seventh standard.
Seventh standard.
Simplex communication, duplex communication. We studied it in seventh. I think seventh class.
I don't know. I studied in my BTech. It
Yes.
seems I'm very poor. I don't know. In seventh class, sixth class, I didn't. I might not have studied such things. Okay, whatever you remember, that's great.
I don't know. They used to teach us the basics of communication. Like one is वो जो when the communication was getting discovered, the scientists were discovering how to communicate. You just need to take a bowl, then you need to like make a like a semi sphere, and then you connect the two wires, and then the one is listening and the one is speaking. So they used to like teach us like this. This is simplex. This is duplex. Like we used to learn this like this only.
Okay, 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 good. See, earlier we used to create uh, create construction by using new, right? New keyword. Whenever there is a new keyword, it will create a constructor. But in UVM, we'll use create. The create method allocates a new object of the same type as this type of, and it returns via base UVM object handle. Okay, this will return via UVM object handle create. Print method d prints this prints forget about it. Create is very important. Create and print method. Okay. Print means it's a printout, uh, uh, print ln, such kind of stuff. You need not to put much here. Control information, memory sequence item extends. See, extends keyword means this is a base class or a parent class. This is a child class or a derived class. Control information, rand bit 3 down to 0 address, rand bit write enable, rand bit read enable, payload information, rand bit 7 down to 0 w data, write data, rand bit 7 down to 0 read data. Okay, this is utility and field macros are same. Okay, same thing.
Okay.
Constructor we are creating with again new only. We are not using create as of now. Okay, and we are giving constraint
Okay.
as write enable and read enable both should not be one at a time. If it is the write enable is one at the time, read enable should be zero. If write enable is zero at the time, read enable should be one. Okay.
And this is off duplex.
Okay. Module sequence item TB. We are writing test bench for this. Module sequence item. We are creating an instance or a handle sequence item. Initial here C. Sequence item, mem sequence item, scope resolution operator, type ID, create. This is creating. Now here creating. Okay. Create method. This is
Okay.
create method. Randomizing the sequence item. Sequence item dot randomize. Print the sequence item. Okay. Sequence item dot print and end. So how many uh, random values will be print right now?
We need to check.
By seeing the code, you tell me.
Just give it a second. You're also teaching in universities.
Huh?
You are also teaching in universities.
Yeah.
Two raised to the power 8 number of values it will write now.
Yeah, you're right. Wait, one sec. Where is that? Okay. Shall we run this? How? What happened? How many errors are coming? What is the problem? It is telling first line itself is a error. How come that is possible? Here exam. Okay. Sorry for disturbance. Some work came, so what is- okay. We- Hello, am I audible? Neha, respond.
Hello.
Okay.
Hello.
Yeah. Thank you, Gopal.
Yeah, you can continue.
See, now we want to display. See, hello world.
Mm.
So we will go for simple codes, not for big codes, one at a time, and we should get stuck somewhere. Again, we are searching. Better we'll go for UVM in this. See, tick include UVM macros.svh. This is a basic file. For each and every UVM file, you need to write this one. Like how you will write for mathematical functions in stdio.h in C. Here also for all UVM projects, you need to write. This is called a macro. Okay, macro. Here it is looking like a black box. The entire code is written already written, and we are calling that